again to my channel. Hello everyone, and today we are going to learn about clustering. Let's start. Clustering. It is an unsupervised machine learning technique used to group data points into clusters, or basically groups, based on their similarity. The primary objective is to categorize similar items into the same group while ensuring dissimilar items are placed in separate groups. It is widely used for exploratory data analysis, customer segmentation, and anomaly detection, and many more things. So now types of clustering algorithms. First we have k-means clustering. It is a very popular clustering algorithm that partitions data into KK clusters based on centroids. How it works? It initializes KK centroids randomly or using a specific method, which is k-means plus plus. Then it iteratively assigns each data point to the nearest centroid, then updates centroids based on the means of points in each cluster, and then repeat until convergence. That is when it's no longer it is a significant change is observed. It is best for well separated and spherical clusters. Then we have hierarchical clustering. It builds a tree-like structure of cluster represented as a dendrogram. Then it adds of two types. Agglomerative clustering, which is bottom-up. It starts with an individual data point as clusters and then merges them iteratively. Then we have divisive clustering, which is a top-down approach. It starts with all data points in a single cluster and then splits them iteratively. It is best for data with hierarchical relationships. Third we have is DB-scan, density-based spatial clustering of applications with noise. Description is group points that are closely packed together while marking points in low-density regions as outliers. So the key feature is that it does not require specifying the number of clusters in advance. It can identify clusters of arbitrary shapes. So we have parameters here as epsilon or epsilon, and it is the maximum distance between 2 points to be considered as a part of the same cluster. Then we have PTS, minimum number of points required to form a dense region, and it is best for noisy data with clusters of varying shapes. And then we have fourth one is mean shift clustering. So it is a non-parametric algorithm that shifts data point towards regions of higher density, thereby identifying clusters. It works as it starts with all data points as centroids, then iteratively updates centroids by moving them toward the mean of points with an undefined bandwidth. It stops when centroids converge. It is best for clusters with variable densities and unknown shapes. The advantages of clustering. So it is customer segmentation first. That is grouping customers based on behavior, demographics of or purchasing patterns. Anomaly detection. So basically identifying unusual patterns or outliers in data. Then we have is image segmentation. It is dividing images into meaningful segments for analysis. Then we have is document clustering, organizing similar documents for topic modeling or search optimization. Then by choosing the right clustering algorithm based on dataset characteristics and objectives, clustering becomes a powerful tool for unsupervised data analysis. So first is demonstrate application of k-means clustering. It can be applied to the Iris dataset using Python, and the code includes comments, optional evaluation with ground truth tables, and improved readability. Like for setup, we will use k-means from sklearn.cluster to apply that k-means clustering, then standardize the data into standard scalar for better results. Then we'll find the optimal number of clusters. Then we will use the LP method by plotting WSS for different values of k. Here's an example. First, we'll import all the libraries: k-means, load average, standard scalar, and py plot as plt. Then we will load that iris data set, then standardize the data, then perform k-means clustering, then extract cluster labels and centroids. Then we will visualize that cluster results and then show it and display it. Then we have that the k-means object has a fit model that performs clustering, and labels will provide the cluster assignments for each data point. The elbow plot show WSS for different values of k, therefore helping to select the optimal number of cluster number. After clustering, data points are labeled by cluster and it can be plotted in 2D or higher dimensions. Okay, so this was all for today, and thank you so much for watching and listening so patiently. Thank you.